Well, why don't I go ahead and get started. I'm Brian Freeman. I'm from AT&T, distinguished member of technical staff, which mostly means that I've been around long enough that I know where all the skeletons are buried and have kind of seen everything that's gone on. I'm going to represent some work here from a great team back at AT&T. Dan Timoney's the lead implementer, PTL, guy in the forward corner. Any of the hard questions that I can't answer, hit him up about them. And he and I have been working together probably for a way long time that he probably doesn't want to admit, and my gray hair probably attests to, okay? I'm going to talk about AT&T and OpenDaylight and a platform for programmable service logic. I'm going to do a little bit of slides that'll be boring but lay a foundation. I'm going to do an interactive demo where I kind of demonstrate how service designers create service logic, and then move into some more architectural pictures and a summary with where we want to go. The service logic interpreter is the thing that we have done to create this platform for programmable logic. You can read the text. It's a domain-specific language. I'll show you a little bit of examples of what it looks like at runtime and how we create it. But our whole idea is to be able to make it easier for service designers to create software-defined network solutions. Okay? We do it within the eComp framework, but it can be used in other frameworks as well. But I will cover the language itself, the main constructs of it, how we extend the language, the things that are being used to in our services today to add to the value. A little bit of the graphical user interface, not because it's the main thing. It's actually a very small piece of the overall programmable platform, but it's the best way to demonstrate the power of the nodes that you can collect and assemble into directed graph. A little bit on the integration points. Why that's important is because we want more integration points with ODL. The two that we have today are good, but we would like more. And then, like I said, some of the enhancements that we would like to see in OpenDaylight as we go along. Okay. So what is a program or a platform for programmable service logic? You can read the slides as well. It's an application that is going to interact with the network through APIs. We don't care whether it's OpenFlow, BGP, PCEP, NetConf. That doesn't matter, but the fact that it's an API-driven interaction is the key part of the programmable platform. It's also applications that do resource assignment. Usually you need VLANs, IP addresses to pick a port, to pick a location, to generate a host name. Do all of these resource assignment functions are part of what it takes to put a service into the network. It is also the point at which we implement the engineering policies, no more than X on Y, make sure that our resource constraints are satisfied, our security constraints, all of those things are implemented and contained in that programmable platform. The last thing, it's the place where state about the network is maintained. That means customer data. We have the information about what the customer ordered or requested. Ordering is the ordering systems up north, but what they requested, the mapping of that into network, the mapping of that into device. Okay? And finally, this language deals with, as I just kind of inferred, these three separate models of what's going on. Very important to us is that there is a service model that is a minimum data set, those things that we get from the upfront systems or from the requests from the network. That translation into the network data, what protocols, adapters, types of network constructs we've selected and modeled. And then lastly, the translation of that into particular devices that we want to configure, signal, update, maintain. That mapping is what the directed graphs do. The Yang models themselves do nothing to convey what's the sequence of filling out the items, the leaf lists, et cetera. What rules do you apply to fill out a leaf for a container? That's what directed graphs do. They are that glue that lets you map from service to network, from network to device. Okay? We also want to do all that without having to recompile code. Services change, network engineering policies change. The mapping from service to network can change over time. We want to do that without having to recompile code. Because service designers are not usually Java developers. They're not professional software people. They know how to think logically. They know a lot about network protocols and the network, but they don't worry about memory management. They don't worry about, we don't have pointers, but class overrides and reflection and all those things. So we want to create an environment for that. So what are the goals of this? You know, you can kind of see that already. Hide the complexity. We want to hide the complexity of software development from service designers who know about services and know about network, but don't know about coding. They don't know about the class libraries, et cetera. We want to create reusable functions because two service developers, two service designers who might sit in cubes next to each other don't realize they both need the same function. So we want to drive reusable components that they can put into their individual directed graphs. Mechanism to change the network and the customer without code change, you can see that, without a code release. Create the mechanism for the mapping between these functions, service network device, in a repeatable pattern, so that if you build service 1, you can build service 2. Someone can debug service 3, that they're all unaware of the main mechanisms for doing that. We talked about the map, the ability to find new service APIs. In most large companies, there's a large IT organization that you have to fit into as a controller. So you want to be able to have automated model-driven ways to create those northbound APIs. And we're heavily invested in Yang tools, all those things. And then the ability for service designers who do have software development skills, there's a small set that do, allow them to create their own user-defined nodes. The ability to add to the language for functions that they want to do or need to do for their particular service network device capability. Okay. Overall ecom architecture, just to frame everybody, if it's a Brian Freeman presentation, a green box is a controller. So for us, on the left-hand side, under network and transport, there's an SDN controller, and also the app-C as an SDN controller. Both are ODL-based, both run the service logic interpreter, both run directed graphs, both map service to network to device. In the SDN controller space, it's layer 2, it's layer 3, dealing with BGP, dealing with PCEP down to the core network, dealing with layer 0 interactions through OpenROADM. In the app-C space, it's doing layer 4 through 7 configuration, it's doing VNF management, it's doing all those things that Chris Rice had on a slide at the Keynote, restart a VM, the VNF manager kind of functions. Same technologies, same directed graphs, a few differences in the nodes and adapters they use, but basically the same functionality being consumed in both cases. Okay? If we blow up inside of a controller, and you may have seen this slide before in previous discussions, we have a base of OpenDaylight that we have added to a couple of components. If I start from the bottom up, we've added the service logic interpreter, this thing that will execute a script deciding which Java classes to execute, passing memory structures between those classes as it's going along. It will write to the config tree, it will read from the operational tree, do all the things a normal ODL application would do. It also has a MySQL database that we use for storing some data that doesn't fit very well into an empty SAL model. If I've got to search and find some optimum resource, et cetera, I have linkages into a MySQL database. North of that is the directed graph, represented by a little blue scroll. It's a piece of XML that gives you an acyclic directed graph to execute at runtime. It goes with the Yang models. It references data items, leafs, and containers that are in the Yang model, but they are separate entities. The Yang model is the what you're going to be dealing with. The directed graph is how do I fill out the Yang model, what steps I'm going to do. Finally, the make it pretty and usable on a day-by-day basis is the DG builder, directed graph builder, a JavaScript Node-RED application that allows us to interact with the language, drag and drop from the left-hand side, put them on a palette, and be able to do those executions. And I'm gonna demonstrate some of those things. Okay. The rest of this is generic. We use adapters from ODL depending on the device types. We create our REST APIs via Yang tools for the northbound systems, all that stuff. Okay. So let's talk about what it looks like inside to a service designer. What do they care about? There's really only 4 things they really care about. They think of the northbound API handlers, that thing I get a Yang model, I define RPCs in that Yang model, and it will auto-generate my northbound API. I don't have to worry about it. I don't have to write code. Yang model, boom, now I have a northbound RPC. Service config operation, whatever it is going to be. What we also have to do for them is write a small helper script that translates those hooks into the thing that finds and launches the directed graph that matches the RPC. And I'll show you how they communicate that to us. But a small piece of code that we provide them the first time for their first application. The directed graphs themselves, a series of nodes. It's an acyclic directed graph, if you know the terminology of this kind of stuff, that contains the flow of data. It's just a set of nodes. All right? An example might be the service config operation that you can see in the black. Start at node 1, go to node 2. It says go to node 7, then on to node 53, and then node 7, and back again. Okay? You're just running through the graph, execute again. Right? One of the nodes at the bottom of that might be a node that says go configure a device. Classic kind of thing, and I'll show you how one of those looks like. Right? Another example might be a notification. If the southbound part of the network or an adapter that we're using southbound has something event that it wants to tell the controller about, it can send a REST API notification. It can come in, launch a directed graph, go off and do its thing. Okay? So for the service designer, they're thinking about stuff that can come in from the traditional northbound systems or stuff that can come in from the traditional southbound systems, triggering directed graphs. Okay? Those directed graphs are what are doing the mapping. Map from service to network, map from network to device, and go off and do their things. Okay? They know there's a SLE, but all they really know is that the SLE is executing the directed graph. They don't have to know about the internals. They don't really have to know about MT-SAL. We hide that from them. We give them a pointer into context memory, and they're just operating on variables in their namespace. They never really know where did they come from, which ones got saved, that kind of stuff. And then lastly, a config node. They do know about config nodes. They have to pick from them which things they're going to use to configure which protocol in the network. And those are the Java plugins that control everything. I can take questions anywhere you want.
So the SDN controller here, which piece is not already in the platform?
None of this is already in an out-of-the-box ODL. Right, right. I guess maybe the API handler. The API handler, the Yang to REST northbound, is out-of-the-box ODL. Everything else is the environment we've created on top of it. Okay. Yes?
Yes, there are a lot of DSL right now. You know that Tosca vendors also recommended BPMN.
So there's a lot of discussion of orchestration, which is where I kind of put the BPMN kind of world, and Master Service Orchestrator and eComp has that. In this environment, this is meant for the 50 milliseconds time scale. So it has characteristics of a BPM, except this is an all-memory, fast runtime execution environment that we've created. And there are many ways this can be done. This is the way that we want to be able to do it.
AT&T specific language.
This is an AT&T specific language. We are putting it into open source. It'll be part of Open eComp. So the SLE, the language, the set of mandatory nodes or basic nodes will all be part of Open eComp when that occurs.
So
Okay.
when vendors participate in eComp, then we're supposed to
They get this.
no
Yep.
other option.
Not an Open eComp. Okay.
Brian, you mentioned that it's an all
Yep, sorry.
memory execution here.
Yes.
Where's the bottleneck that you foresee because of that? And the question really is background for, have you looked at doing this as a microservice outside the controller that then calls into the controller at the end node, whether that's through a notification or
Hopefully everybody can hear his question. So just generally, have we looked at using this as a microservice outside of the controller and calling in? I'll try and remember that for other folks too. We haven't looked at it that way. We actually think of this as a way to string microservices together. So you'll see me talk about execute nodes, which is the way to do an arbitrary function in the middle of a directed graph or as part of a directed graph. So we actually think this execution environment is the place that we are going to use to call other microservices. I think the bottleneck, which was your other question, is actually the on-data tree notification and how fast we can do write transactions to a clustered MD-SAL. That is our bottleneck, right, in all honesty. That is an ODL bottleneck. You can only be as fast as an adapter can read from on-data tree notification, and if it needs to update, to write to the transaction. Those are the problems. The DGs can be cached in memory, a whole bunch of things that go on. Go ahead.
Okay. So the graph execution is static, how can we generate it on demand?
It is, in today's world, we preload the DGs. We can update the DGs on a running OpenDaylight controller. DGs can call other DGs. We do not yet today automatically generate DGs. There's nothing to prevent us from doing that. There's risks with auto-generating DGs, but you know, we haven't had to auto-generate them yet. Most of the paths through this decision logic you know about in advance, that before a packet or an event arrives, you know where you want it to go, right? But we could do an auto-generation if it made sense. Okay, I'll take one more question and then I should get on to the next part.
We need one directed graph for one service, what we for others for multiple services.
We've done it both ways. Because you can map your input to go find the directed graph, you could find a common directed graph that replies to 7, 10, 100 different types of events, and then you parse through memory to decide what you want to do. We've also done you've got an RPC, you get one directed graph. So
There are some conflict between the services. How can you handle that conflict?
well, remember, it's the service designer who is deciding this. So a service designer could say, I want to have my own start point. Service designer could say, I actually have 15 different RPCs that I support, and I want to have 15 directed graphs for that. Or they could say, I have 15 RPCs and I want one directed graph for my service, and I'll decide what I want to do in terms of calling subgraphs as part of that.
But we have multiple service designers. They can model payload,
So then if they don't agree, then each service has their own kind of helper function to do the segmentation. That also helps with the bundling when services may or may not want to be co-resident, which you'll see in like the second to the last slide. That sentence will make more sense. Okay?
To elaborate on that last question,
Mm-hmm.
is there any mechanism to deal with, you have two different directed graphs that are responding to two different events that are producing conflicting directions down to the network to try to drive, I need to set this queue to this link, no, I need to set it to this link, or change its priority, or any of the myriad things you have to do to keep the network operational.
Yeah, we think those come together at the config nodes, the adapter nodes, is where you would do the resolution of those entities that are hitting a particular device. And so the reason we've kind of separate out config nodes from everything else is that's the part that has to be aware of anything unique and don't break the network kind of rules, right? You know, so that's how we would do that. But directed graphs, you have to be smart about what you're doing and making sure that you avoid, you know, really, really bad things, right? That's just like in anything else. But most of the network guys actually get it because they've seen it in the past. And so they are the ones asking us the questions. How are you making sure that config node is the right thing? Okay, all right. Okay, let me move on. So two basic mechanisms. Today we predominantly use REST RPCs. Because the majority of our interfaces really are synchronous for the things that we're doing. It permits the directed graph to control the HTTP response. And that's kind of critical with some of the business operations. We would much rather use on data change notification, on data tree notification. But we have no way to control the response code. So things go in, RESTconf is fired, you get a 200 OK, it's in the MD-SAL, then the directed graph can fire. And that works for Neutron. Does not work for many of our other business operations. We really need what's called a pre-commit hook so that we could fire the directed graph and control what the response is going back to the upstream systems. It's a minor technical thing that drove us crazy the first few months, trying to figure out how to get the leverage of RESTconf without having to go into RPCs. But we've had to go into RPCs for almost everything. Okay. And I talked about the helper code. Okay, what does a directed graph look like? When we started this, the left-hand side is what we were making service designers hand code or hand create, okay? XML document, and you probably could use a bunch of XML tools, but you got to worry about the start tag, the end tag, put it in, make sure all the closing tags occur at the end of it. And then you could see via GraphViz and a version of that. When we were doing this, after about 8 hours, we said there's got to be a better way to do this. Okay, it's not gonna work. Okay, so that's when we came up with the Node-RED DG Builder that we actually stole shamelessly from another AT&T project called Flow Designer that was doing a similar kind of thing for Internet of Things. And we kind of stole the graphical environment, et cetera, from work that they had done. The important point that the reason there's the two red boxes is in the Yang model for a service, you would do something like this is the layer 3 SDN API, and you would define a RPC. That's actually the header you want to put in the directed graph so that we can find that directed graph in the database. That's the kind of like the only key thing that relates DGs to Yang models, at least in the standard RPC mechanism. But you can actually play with this in a bunch of different ways to go find the DG that matches the event that came in. It also doesn't have to even be an RPC. You can launch a directed graph from a BGP update, from a BGP link state change, variety of different, you can do it off a cron job, variety of different ways that you can launch DGs in the environment. Okay, so the new interface looks like this. You kind of saw this from Chris Rice the other day. I'm going to try and demonstrate this if things go right. So I just have VirtualBox. I have a Ubuntu machine running. I have the DG builder running as a process. So it's Node-RED, et cetera, et cetera. You can start with a blank palette. This is just a record of DGs that I've got currently running. Standard kind of stuff to see stuff on the left. If you've used Node-RED, kind of things you'd expect in a graphical experience is you can copy and paste whole segments of the tree. This one happens to be the runopt API version 0.0. Let's call it 4, so I don't confuse it with other things. When we put things in the MySQL database, we version the directed graphs. So when we go run an event, we pull out the highest version directed graph. If that's a bad directed graph, we can deactivate it and make a previous version active. We can also do things like run tests against the latest one before we move all of the traffic to the new directed graph, that kind of stuff. Okay? But you also would say, I want to use this for the RPC called the service topology operation. I want it to be sync. There's also the capability to be async capabilities. There's usually a little helper test when I'm on a node that changes to tell me what I want to do or what this node does on the right-hand panel, just as you're navigating through things. Okay, but let's say we're doing this directed graph. Runopt is going to do optimization of the network in this normal Yang model, but let's say we're going to do something like create static routes. Normally, you would create a block or use a block node. Block node just says, for everything that's attached to this node, do it all. If they all succeed, you get success. If something fails, you roll them back, okay? It's a failure event. So let's do a block. Let's do something, if we look at the set of nodes that I have access to, I have something called a set node. And a set node does something really fancy like set variables, right? Very, very fancy naming that is going on here. A set node could take the name of a parameter, which might be temp dot some variable, and you could give it a value 1, 2, 3. I can copy this, and I could say some other variable, and I could say instead of an actual string, I can say I want to use the dollar, service data dot static route, if I knew that was a variable that I had in my equation, in my Yang model. If I didn't really know what my Yang model had in it, I could, if this thing will respond correctly, I could pick parameters like out of my runopt-API Yang model, I might pick the request ID and say, go ahead and add that as a parameter to my logic. Okay? I think I've added it twice. That's probably not what I wanted. There we go. Okay? And so I'll delete the last one from the logic. Okay? So this gives us the capability not only to set variables that I might want in my directed graph, but allow me to reference other pieces of context memory that came in. So before we launch a directed graph, we look in MDSAL, we look in the other database, and we create an in-memory data structure, basically a set of leafs that is context memory that the directed graph can operate on. Anything that's in that Yang model, we will save to MD-SAL at the end. Directed graphs can create variables on the fly as they're executing. First node operates on context memory, and then when the second node takes over, it sees all the changes to context memory that had occurred for previous graphs. And so that's a way to communicate between nodes, the state of this particular event, this particular transaction. Okay. Okay, so let's keep going in our example here. Let's say I've set a bunch of variables and now I want to go execute a microservice transaction. I will now go in here and say, let me go reference, com.att, some microservice. And maybe the right one I want to use is SDNCTL-IP address tools, and it might have some method called calculate static routes. And I might, pass some parameters into it, a bunch of different things that might happen. But when this node executes, it will go off, take pieces of context memory. I can pass in branches of the tree, branches of the context memory to the node. It'll go off and execute and can return branches of the tree for me to operate on. And so we use this for a bunch of different things. Sometimes for east-west API calls, going out to IP address management systems, doing updates to active and available inventory, variety of things like that. We might decide at this point that we want to do a configure node. And so we might go off and go to com.att.sdnctl.netconf node, pass in some key that makes sense, like update static route, and we want it to go through and do an activate. There's a bunch of text over here that explains the things that go on in a configure node, all the online help that you'd kind of expect when you're dealing with that kind of stuff, okay? And so, we look over here and we say, okay, I've done everything. Maybe I want to save my data or some piece of the data to the MySQL database. I can go off and see that information. I can click here, drag and drop. And maybe the last thing I want to do is return a success. Trust me that if I open those up and go fill some stuff in, that I could make them all happy, okay? And so I've done that. I always got to remember to deploy, all that kind of stuff. Service designer tests this. It all works good, but this is like a sunny day condition, right? There's no error tracking, et cetera, et cetera. So again, is another way to explain some of the things that go in the language. Well, why don't we do an outcome box where we say, well, let's do something if it's true. Let's do something if it's false. Let's have a general case of other, right? And let me go see if I can find my switch statement. That's S, right? Yeah, here's a switch node. I'll go delete that linkage, create a linkage to here. I will go test some variable, service data dot some Boolean. Trust me that there might be, I can fill in a correct name there. This will be a Boolean test. Off it goes. I can now link that to the case when it's true, go off and do this stuff. If it's false, I want to return something different. And in fact, both of these nodes can be mapped to the same output. Okay, and that output, say I want to return I look up on my little table, I want to return a 403, bad data input, whatever you want to have to do, okay? I can go off and save that. I can go off and do things associated with it, like validate that everything that was generated makes sense. They didn't leave off a tailing parameter. They didn't add an extra quote on a string that didn't need to be there, all the things you'd expect. I can email this directed graph to my partner and have them check it, or use it in their environment and test a node. I can upload it directly to the OpenDaylight test environment that I'm using. Go view the DGs that are in my instance, all these other kinds of things, okay? This is what kind of like that example looks like, a little bit more filled out. Here's one for doing traffic engineering with PCEP tunnels, where you can have a variety of different outcomes and nodes. You can have nodes in the directed graph that aren't linked in or are only linked in for test. like print context. That's when I like to link in when I'm building a new DG. What exactly did I get in from the event or from the northbound system? Save all context back to a file, a bunch of supporting functions like that you can all interact with. Okay. So let me go back to our presentation. Check on time. Okay. So I've showed you a little bit about the drag and the drop, et cetera. But you should get the sense that what's in this language. There's a bunch of flow control primitives that allow us to deal with how we're navigating through the directed graph. A basic block that says do this as an atomic thing. I can have multiple blocks in a directed graph, and they can call each other when that makes sense. A basic call node that I didn't demonstrate is the directed graph that I'm in can call another directed graph. And in fact, we do that where we have basically a starter directed graph that does the basic triage of what was the transaction trying to do, and then calls a piece of reusable directed graph logic for that event. And then we can so that we can share directed graphs across things. A for loop, particularly in the TE tunneling space, we have to loop through a series of requested transactions or a series of links in the MPLS tunnels and decide what the next hops are going to be. So we use for loops for that, as you'd expect. The set I demonstrated, the switch I demonstrated, both basic operations, set a variable, set a temporary variable. Those are different things in the directed graph logic. And then just switch on any variable and take an outcome. Resource management on the right-hand side. I didn't show an example of that, but we have a rich set of primitives that deal with looking up assets, deciding how to assign them, to release them, if this is part of a disconnect or a rollback or all those kinds of things. We can reserve, we can save, we can update, all the things you'd expect you need to be able to do with resource management. Okay. We have a record node. That's the way if we wanted to tie into recording systems, online detail, call recording, transaction recording, that kind of stuff, you would use a record node that would get it out to the systems that need to do that. The two I left for last are device management, that's the configure node, and then the Java plugin support, the execute node. Those two nodes have this kind of unique thing is you can create new ones from existing ODL adapters, from legacy code that you want to interact with, or brand new code that you need to write to solve a business problem. They have a particular signature. We will pass in, you basically are writing these nodes yourselves. They will take in a map of the parameters that were in the node of what got passed in. They'll have a pointer to the service context. The service logic context is that Yang tree that is the variables, containers, leaf lists, et cetera, that you can operate on in context memory. And that when they're defined in the Yang model, they get saved in MDSAL. If they're defined temporarily via a set node, they are not saved to MDSAL. You have to save them as part of the directed graph, right? But that you can create new execute nodes. We have, for example, one that's called IP address tools, real fancy name. I think I probably named it. That's why it has a not so very fancy name. But it does, route manipulation, net masks, get the subnet, do all those things for v4 and v6 that you need to do. You just the mathematical parts of manipulating addresses. We have a generic REST API call. Turns out that most REST API calls kind of look the same. The payload has a template with variables in it. I have a URI. I put SSL on or off. And I can use that as a node that I don't have to code every time everybody else has to use a REST API. We have a node that deals with v4 and v6 public IP address management so that we can get out to IPAM systems, get an address based upon a IP address plan, and get a block or a particular address back from. And those succeed or fail. It's an execute node. It does its thing. It manipulates data in and massages the data on the way back out. Configure nodes are different. These usually have the capability for rollback. If there's an event, they may have asynchronous capabilities. So, a longer list. That's why you can pass in a key to a configure node that says, hey, you as a configure node, you do a lot of different things. I want to trigger this behavior. BGP4 update, IPv6 flow spec update. Might be examples of those. And so those generally talk to ODL adapters, the BGP, the PCEP. They also talk, netconf to the ODL netconf adapter, Also, we have our legacy CLI adapters. We have 10 to 15 years of rich and robust history of dealing with Cisco and Juniper, et cetera, CLI, and those have APIs. We have bundled those adapters into nodes for the directed graph. And then we also deal with EMS-like things that we call the smart CLI adapters, for want of a better name, that deal with those things where there's more intelligence in the adapter layer. Okay. From that base language and the capabilities that are existing in all the directed graph nodes, the new execute nodes and configure nodes that we've generated, we have, as an example here, 6 different types of SDN controller that have been built upon the basic SLE and SDN controller capability. Something we call SDNG was the original SDN global controller that we used for network on demand. It's now a year and a half ago when we first came out with that service. It does resource assignment, inventory, and config management for our layer 3 VNFs in the AIC cloud. Does it well. We quickly realized that the G part of global really wasn't global because the next thing that came up was AppC, application controller. It's doing a similar thing, layer 4 through 7 VNF configuration and VNF management, but it's a different set of directed graphs, it's a different Yang model, different set of southbound adapters. Here it talks to OpenStack. SDNG never had to talk to OpenStack. It was actually, SDNG was a neutron agent. You know, it was a client to OpenStack, whereas AppC is actually the thing calling OpenStack as a VNF manager. But again, a different set of directed graphs, different set of Yang models, same ODL controller software, same SLE software, et cetera. We do IP flow to redirection. This one's going to be unique from the standpoint it'll be geographically distributed. Every region of the world will need a BGP flow redirection capability because we don't run BGP over the undersea links. So Asia Pac, EMEA, Latin America will all have SDN flow redirection capability nodes that are deployed for unicast, flow spec, all that kind of stuff. We have our MPLS traffic engineering application. This is doing TE tunneling, BGP link state, listener, going off and making changes to the network based upon those things. It'll be separately deployed just in the US because we don't do this activity in our other subnetworks. But it'll be another instance of the same thing. Different Yang model, different set of directed graphs, 70 to 80% reuse of the nodes that are inside of it, but those things that are different, they'll just trigger that. And you can read that there's something called NetBond that we do with our cloud interfaces. And we've brought the operations teams into writing directed graphs, using nodes in the directed graph language to solve operations problems. So they now are service designers inside the SDNC environment and the SDNC eco-family, ecosystem, I guess is the better word to say. So we think that's actually part of the secret here is bringing operations into the API user community in an SDN controller platform.
That's just a question. Your block structure is for sequential execution. Do you have something for responding to parallelized execution? Because operations frequently wants to do things in parallel.
Yeah. So first off, because they can do multiple executions. You can call the controller multiple times from the front end, and we do that kind of stuff. We also have some threading that we are capable of doing. We find that what they're doing more of is, since their directed graphs are independent, they actually are doing 5, 6 steps within their directed graphs. They're doing the multiple things in one shot because they want to say, I run the following 7 things for health diagnostics when it's a Juniper device or when it's a Cisco VNF. Run those 5 or 6 things and give me back success fail for the total of the 5 or 6 and the details for each of the steps that ran. Because if it's success on the top one, great, we're done. If it was fail, I need to know which of those 5 or 6 diagnostics went belly up, and then they can dig a little deeper, that kind of stuff. But ODL, you create more worker threads. So we get 100 requests in, we'll do 100 things in parallel. The adapter is where you say, look, I don't let all 100 people into the device at the same time. I say, nope, you're serialized into an adapter. Or I've got a channel reserved for operations and a channel for config, but the one at a time kind of thing. Okay, so that leads to these kinds of deployment options. Might never do exactly this, but the SLE is a carafe feature bundle inside an ODL controller. I can deploy, let's take the left-hand side one. I can deploy SDNG, SDNO, and SDNW on the same instance of an ODL controller if it made sense for me. Somebody else might rather do SDNO and AppC on the same instance, right? Or just run SDNW on a standalone. These are now deployable options, decisions we can make at deployment time to mix and match these microservices, for want of a better word, on top of an ODL controller. Okay, ODL plus the SDNC, and now you have a runtime environment. Populate in the directed graphs in the car for that service. We're done. You're up and running. We strongly say, if you're going to do one of these things, you got to go through a system test cycle. Only because the carafe is not always great at library resolution and making sure you don't have two versions of the Spring framework running and these kinds of things. So the first time, you got to go through a system test cycle together. And then once you're deployed, you can update your DGs without any foreign entanglements.
Okay, so you have the SDN controller. On top of that, today, you formulate the layer for orchestration. So all the red boxes are part of the orchestration layer.
No, these are running inside an SDN controller. They're not part of orchestration. These are applications inside the controller. These are SDN controller applications. So that central one on the left-hand side, that's the same host name. There are at least 3 URIs, probably more than 3 URIs, but 3 URIs, one for G, O, and W, right? Controller, restconf, config, or no, it's controller, restconf, operation, blah, 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 something about SDNO or something about SDNW, right? But they co-reside inside that same carafe container, inside that same cluster.
But then the actual application is running on top.
In the these look like brown boxes. What color is that to you? Is that brown? Over there they're orange, but here they're kind of brown. Yeah.
So you have these things which are controller applications.
Yes.
But then they have also a service layer.
They may or may not have a service layer, but yes, there's MSO or upfront BSS, OSS systems are the things that will be calling the inputs into these in some cases. In some cases.
Could you elaborate?
The SDN MLC, it does not react from the OSS side. It sees BGP link state changes, and that triggers a rerun of the path computation algorithm. A decision is made, the current MPLS, someone buried a cow in Illinois, the network reconfigured in a distributed fashion, MLC sees a link state change, on data tree change notification. We start the directed graph. The directed graph says, let me call a microservice to rerun path computation. I will now decide there's a new set of links, new paths for the following 10 MPLS TE tunnels. It will go signal to change the next hops for these 10 tunnels.
So the PCE in that case, it lives inside the controller.
Yes. The PCE adapter, two things. The path computation is inside this application. The PCEP adapter is the out-of-the-box ODL adapter. The BGP link state was the out-of-the-box ODL adapter.
And the number crunching machine is embedded into the web.
Into here. For that particular example, for path computation, we've chosen that we do path computation locally to the controller. We could have queried outboard, but we think the way we look at this is we are trying to re-optimize the network that after the first 50 milliseconds, we want to kick in and create new tunnels.
There is one issue here, just I can see. If you're looking at multi-segment or SDN controller like SDN man, so that entity should have a global visibility into the end-to-end topology.
SDNG should. With respect to MPLS TE tunnels, SDN MLC does have global visibility. It sees all the tunnels that it's going to manage. Okay? Right? But I think federation is a good issue about how SDNG and pick one that isn't co-resident, how do they talk to each other? Like SDNC and AppC, they have a relationship. The layer 4 through 7 will have a relationship to SDNG.
So there are cases that you have a linkage between the SDN, MLC, and SDNG.
Well, the example I gave was app-C, but yes, there will be cases, but that's where we're going to go out and we're going to use either REST between two things, or we'll use a pub/sub bus like Kafka between two things, which again turns into REST. And in both those cases, it'll be an execute or config node in this directed graph that is going to launch a directed graph over here. Okay?
Okay, then the state consistency has to be met.
And then the state consistency is within those two controllers, right? This is where the MySQL database is going to be, in a lot of cases, the point where we start coming together. But directed graphs themselves can be small microservices for other controllers, right? I mean, there's nothing to prevent it. We originally thought directed graphs would be these things, 10 nodes, 20 nodes. The service designers have directed graphs with 300 nodes. And we asked them, why are you doing such large directed graphs? He says, oh, I'd rather do this than have my developer go write the Java code. Because I can do this. I can change it immediately here and get feedback and fix it and tune it, et cetera. But my cycle time with my developer is shorter, even though that's a matter of hours. They can go fix it in the directed graph now. And they really, really like that. And so we've had to expand the column size, that we use in our MySQL database to store directed graphs and all these things. And we've had to work on how much we can see in a DG. What we really think should be happening is that as you get directed graphs that large, you should circle a bunch of nodes and sit down and tell the developer, okay, this has been through 2 cycles. Can you turn this into an execute node for me? It doesn't need to be always in a DG. You can refactor it. And now I don't have to write a Word document on what the requirements are. I can say, here's my DG. I know it works. Go turn that into code. And I will replace this part of the tree with a single node, and off I go, right? And they can always replace it back if it doesn't work, right? So,
How do you synchronize the lockdown model, the YAML model with the DG state? This can change versioning of the data, and now we need to go back and make sure that everything will work.
If you update your Yang model, then you will have to update your DG to deal with the population of those variables that are new to the Yang model. Our rule is you don't make leaves go away. You always add leaves, because if you make leaves go away, really bad data migration problems pop up. But when you add leaves, your old DG works, but it just never populates those new values or uses those new values. But if you change your Yang model, you should update your directed graphs to do something with those variables that you added. Because if you think about the Yang model, it's just the variables. You didn't say how they should be filled out. Right? If it's in your RPC, you had to negotiate with your front-end system to populate those new things, even if it's optional. And again, still, you'd update your DG to match that. Okay? Most of the DG churn is working through the rainy day scenarios that are independent of the northbound system. The northbound system, they sent their stuff in, they're fine. Now it's well, what did I do to it? How did I map it to the device? What do I do if I have a new device that has slightly different syntax? Same input, same Yang variables. But now I have to map it to some different adapter settings, et cetera.
The Yang library, that's going to really adapt to the southbound interface in ODL. Is that Yang, you have to go and change something in the Yang, yeah? Or no?
On the southbound side?
As a part of the adaptation to the...
As part of the adaptation, I suspect the answer is going to be maybe. I'm not sure I'm quite understanding the question enough, but Yang models and what we do are primarily the network, and the service and network is what's AT&T defined. The device model came from the device manufacturer.
So you have two different Yang libraries here?
Well, it's a set, right? They are different files, and it's a set, of Yang models that we have to deal with. We do, but the device stuff, the way to think of it, if it's a netconf adapter, the device Yang model is in the netconf external mount. I don't have to do anything about that. That's auto-discovered, right? The network and service Yang models I author. Those are in MDSAL. Those are in a different part of the MDSAL tree, right? And I, through the directed graph, manage how does the network model get populated and which parameters in the network model go into where in the netconf tree for that device.
So that's an action item for ODL or for...
No, that's my job. I have to do the mapping. right? You know, ODL can give me the capability to communicate the device model to the device, and I depend on that, but I, as an application, have to do the mapping. Because my choices might be different than an Orange or somebody else. I think I've run out of time. Let me just finish this. I'm going to mail this. Yesterday I made a statement. Everybody should hug their infrastructure developer in OpenDaylight who does MDSal or NetConf or any of those, those basic things. But there's like 5 or 6 things that we really need out of ODL going forward. We really need a multi-threaded on-data tree change notification. I think us and Tencent are probably running into the same problem that when you get so many BGP updates, there's just only so much you could push through a single node. We need the MDSal shard management capabilities to move things around and to be able to do elastic growth on nodes. I'd love to have a 20-node MDSal cluster that has 15 nodes for doing on-data change notification for things, but you cannot physically do that in the current architecture, right? You need something else. We would like that on-commit data handler. We've been patient. We've been waiting for about 1.5 years for this. I have a feeling that we're just going to have to train somebody on MDSal well enough to put it in ourselves. And I absolutely recognize that there are repercussions with the on-commit or on-pre-commit data handler, but we'll probably have to go do it. There's a small problem with enums, and this is just if we're using enums, we really should be using identity refs, but in the places we use enums, it's a pain moving back and forth. And then we all need better disaster recovery. We are doing geo-redundancy for the STN controllers. We started with some snapshot replication. We're moving to the non-voting cluster member. I don't think that's quite enough yet. It's getting closer, but we really need to be able to do active-active capabilities with perhaps some form of lightly eventually consistent replication. Colin does not like eventually consistent replication, so he's trying to educate me on other ways to do that. So. Okay, and I think unless there's any more, I'll take one more question if needed, but otherwise we've kind of run out of time, and I hope this was helpful and that you learn now what we're doing in the SLE, why we're doing it, and some of the things that service designers should be able to do out of it. Okay, thank you for your time. Create this platform for programmable logic. You can read the text. It's a domain-specific language. I'll show you a little bit of examples of what it looks like at runtime and how we create it, but our whole idea is to be able to make it easier for service designers to create software-defined network solutions, okay? We do it within the eComp framework, but it can be used in other frameworks as well. But I will cover the language itself, the main constructs of it, how we extend the language, the things that are being used to in our services today to add to the value. A little bit of the graphical user interface, not because it's the main thing. It's actually a very small piece of the overall programmable platform, but it's the best way to demonstrate the power of the nodes that you can collect and assemble into directed graph. A little bit on the integration points. Why that's important is because we want more integration points with ODL. The 2 that we have today are good, but we would like more. And then, like I said, some of the enhancements that we would like to see in OpenDaylight as we go along. They are that glue that lets you map from service to network, from network to device, okay? We also want to do all that without having to recompile code. Services change, network engineering policies change, the mapping from service to network can change over time. We want to do that without having to recompile code. Because service designers are not usually Java developers. They're not professional software people. They know how to think logically. They know a lot about network protocols and the network, but they don't worry about memory management. They don't worry about, we don't have pointers, but class overrides and reflection and all those things. So we want to create an environment for that. So what are the goals of this? You can kind of see that already. Hide the complexity. We want to hide the complexity of software development from service designers who know about services and know about network, but don't know about coding. They don't know about the class libraries. Well, why don't I go ahead and get started. I'm Brian Freeman. I'm from AT&T, distinguished member of technical staff, which mostly means that I've been around long enough that I know where all the skeletons are buried and have kind of seen everything that's gone on. I'm going to represent some work here from a great team back at AT&T. Dan Timoney's the lead implementer, PTL, guy in the forward corner. Any of the hard questions that I can't answer, hit him up about them. And he and I have been working together probably for a way long time that he probably doesn't want to admit, and my gray hair probably attests to, okay? I'm going to talk about AT&T and OpenDaylight and a platform for programmable service logic. I'm going to do a little bit of slides that'll be boring but lay a foundation. I'm going to do an interactive demo where I kind of demonstrate how service designers create service logic, and then move into some more architectural pictures and a summary with where we want to go. The service logic interpreter is the thing that we have done to maintained. That means customer data. We have the information about what the customer ordered or requested. Ordering is the ordering systems up north, but what they requested, the mapping of that into network, the mapping of that into device. Okay? And finally, this language deals with, as I just kind of inferred, these three separate models of what's going on. Very important to us is that there is a service model that is the minimum data set, those things that we get from the upfront systems or from the requests from the network. That translation into the network data, what protocols, adapters, types of network constructs we've selected and modeled. And then lastly, the translation of that into particular devices that we want to configure, signal, update, maintain. That mapping is what the directed graphs do. The Yang models themselves do nothing to convey what's the sequence of filling out the items, the leaf lists, et cetera. What rules do apply to fill out a leaf or a container? That's what directed graphs do. Okay. So what is a program or a platform for programmable service logic? You can read the slides as well. It's an application that is going to interact with the network through APIs. We don't care whether it's OpenFlow, BGP, PCEP, NetConf. That doesn't matter, but the fact that it's an API-driven interaction is the key part of the programmable platform. It's also applications that do resource assignment. Usually you need VLANs, IP addresses to pick a port, to pick a location, to generate a host name. Do all of these resource assignment functions are part of what it takes to put a network, put a service into the network. It is also the point at which we implement the engineering policies. No more than X on Y. Make sure that our resource constraints are satisfied, our security constraints, all of those things are implemented and contained in that programmable platform. The last thing, it's the place where state about the network is